All right, hello and welcome to the ESC and ESC board project. Now, as a grand overview, currently, as I've already mentioned a few times, we have been using the um, Blue Robotics ESCs, which are rated for 30 amps, which is the max the motors can take. Um, at 4S, I think they can go up to 6S actually, but I'm not too sure about that. Doesn't matter, we're not using them anymore. Main reason for that is A, we didn't get any form of data from them. We had to address them all with PWM, which didn't give us any feedback. As well as there just being no more support for the software that they're running, so we cannot flash any new ESCs or update them or whatever. So we're going away from those. We're moving towards an open source project. And the one we settled on was the VESC project. If you Google that, that is VESC project. Um, and they have a lot of data and a lot of adjustability. Everything we're looking for, right? They are designed to be used with longboards, but I do think we can use them with our project, especially as the PCB itself is quite small, and we don't have to hand solder those. So, general overview of the VESC, they're rated for up to 80 amps, the ones we're using, I think. Plenty of power, don't need to worry about that. The one thing I'm worried about is the manufacturing of them, but James has already checked, and we will be sending those to JLCPCB for their pick and place service and soldering service. So we will get those to actually then place all the parts and solder them on there. The ESCs themselves have a built-in microcontroller that runs the VESC project. Let me see if I can start that up while I'm talking. I'm running out of desktops. Um, VESC tool. And that allows us to program each of the ESCs individually as well as together. They all communicate over I2C, and will have their own data line going out of the ESP mobile. Now, in this design suite and design tools, this is something you guys will have to learn about, especially if you're looking into embedded systems. We have a ton of adjustability. We can change pretty much every parameter of the ESC, and optimize it for what we're trying to do. There's a lot of helpful videos online that will help you do that, but for now, before the October 15th deadline, I want to worry more about the actual technical implementation. So here we go. This is the basic ESC that is, or the PCB and the schematic that is provided by VESC, the open source project. And that gives us basically the entire ESC plus a list of components. Um, and that is we don't have to mess with that. The one thing I do want to change, and that I just mocked up here real quick, is to add some mounting holes. So I want mounting holes that connect power and that connect the three outputs of the ESC, as well as some headers that connect to these and pins. So we can just place the ESC on there, screw it in, and have that transfer the power so we don't have to worry about cables getting tangled, cables going everywhere. So that's the plan with that. In terms of, so basically you have your three phases for your motor coming out here, and where initially you just soldered to these pads, I went ahead and added three mounting holes, and those will then allow us to screw to a specific component, and that would be this component right here, which is basically a solder on connector that is able to handle the 30 amps going through there. And that will then be soldered to the ESP board. Now, moving to the ESP board, because we're pretty much done with this, I want a hole for VCC as well, and a hole for ground. That's something I was not able to figure out yet, but I'm sure you guys will. Now, also yeah, anyways. Now, let's look at I just mocked this up. Again, not the best mock-up, but should work for purposes of demonstration. We will have the component I just showed soldered to here. And that's where the ESCs will screw into. And the placements of these is just arbitrary right now, but and then this is where the three-phase output of the ESC will also screw into. We will then have header pins for the CAN bus, PWM. I basically want to break out everything and then bring it over here where we'll have outputs for all of these, where we can then daisy chain the ESC boards. We'll have 3 of them stacked, each having 3 ESCs on them. Either daisy chaining them or connecting back to the ESP motherboard. Probably have an input and an output side for that, where we then send the CAN bus and I2C through, or PWM, depending on what protocol we decide on choosing, or I just want the PWM as a backup. But Andre knows a lot about this. Then, in terms of mounting, the ESCs will be mounted. Let me just open my preview. 3 over each other. We can fit this. This is an actual mock-up of the size of the PC, the ESCs and the board max size. We can fit 3 of these over each other. I want some sort of active cooling system for these as well, but that's more going to be on the thermodynamic side and in charge of the mech team. And we'll have 3 of these mounted together. Now, what right now the issue is we need to connect each of the motor cables separately. So we have 8 motors, each with 3 cables. That's 8 times 3, 24 cables that we need to connect to the right corresponding ESC cables. I want to get rid of that. I want to instead use high current connectors, as can be seen here. These should be able to handle the current of the ESCs, and these will be then mounted to the ESC board up here. So that means the 3-phase current will go through the board to these connectors, and to these connectors we can just plug in the motors to, with all 3 wires of that motor already arranged in the right way, right? I think that's pretty much it technically. If you have any questions, feel free to contact me. I mean, I know it's both you, James, and Andre working on this project, so we've done this before. We can do it again. We just got to make sure that it can handle the 240 amps that come through it if all motors go to 100% blast. As well as integrating some fuses. So I want to integrate fuses between the VCC that if we go over 30 amps blow instead of blowing up our motors. We can also set that in the software of the ESCs, but I just want a redundant system. Perhaps we can even connect these fuses to make them software resettable, or I don't know. But yeah, that's the general overview. There's again a lot of ambiguity to it. That's intentional. Feel free to design in whatever way you would like. Just make sure to stay in contact with me. I will be your pointer person for this project, and we'll go from there. Thank you guys. Oh, sorry. One more thing. For the design review on Thursday, I would like to have all of these components finalized. I want to know which ones we can use, if they can handle the current, and if they are available. I also want to finalize if we can do those changes to the ESC board, the ESCs themselves, just to make sure that we can actually make those changes and then have them also shipped already picked and placed. So James has already checked with JLC, I believe it was, if they have the components. They do, except for the STM, which we'd have to order to them. No big deal. We can do that. I think that was it now. Yeah.